Welcome viewers, in this video we will see the details about the hop subtractor. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will see, before going to the hop subtractor, we will see the what is the subtractor operation available in the digital electronics. The subtraction consists of 4 possible elementary operations, right? The subtraction means subtraction of 2 binary digits, right? So there are 4 possibilities are available. So the first one is 0 minus 0, very simple. 0 minus 0 will be 0 only. 1 minus 0, from 1 if we subtract 0, again it is 1. From 1 minus 1 also 0. From 1 if we subtract 1, it will give 0. So 1, 3, 4. First, third, fourth is very simple. 0 minus 0, 0 only. 1 minus 0, 1. 1 minus 1, 0. That is very simple. But the second one, 0 minus 1. The first number is smaller, second number is bigger. So in that case, we can go for a borrow. We need to borrow the number from the previous digit. That is, the first number is 0, second number is 1. We need to subtract. So it is not possible. We need to borrow the one number from the previous digit. So while borrow, what will happen? It become 10. The 0 become 10. What is 10? 10 is nothing but by the decimal equivalent of 2. So 2 minus 1, 1. The difference is 1. Right? So borrow also 1, difference also 1. See this. 0 minus 1, the difference is 1 and with borrow of 1. Right? So I will explain again. 0, 1. We need to subtract 0 minus 1. So 0 minus 1 is not possible. So we have to borrow the one number from the previous digit. So we'll borrow 1 from previous digit. This 0 become 1 0. Right? So from 1 0, if we subtract 1, we'll give the difference of 1. How it is? 1 0 is nothing but decimal equivalent of 2. Right? So 2 minus 1, 1. So the difference is 1 and borrow also 1. Right? The difference is 1 and borrow also 1. Right? So for the 3 combinations are very simple. 0 minus 0, 0. 1 minus 0, 1. 1, 1, 0. Only the second one, 0 minus 1, having the borrow. We need to go for a borrow 1. For that, the available difference is 1. Right? So this is the basic concept of the subtractor. Now we will see the description. In all operation, each subtrahend bit is subtracted from the minuend bit. In case of second operation, the minuend bit is smaller than the subtrahend bit, hence 1 is borrowed. So it is just like the half adder and full adder. Similarly, we have hop subtractor and full subtractor. So hop subtractor is a combinational circuit that subtract 2 bits and produce the difference. Right? So hop subtractor will perform subtraction of 2 bits. Full subtractor will perform 3 bits. It also has an output to specify if a 1 has been borrowed. Right? So it will give the details about the borrow also, whether the 1 is borrowed from the previous digit. Right? So there are 2 inputs and 2 outputs. 2 inputs AB and 2 outputs, difference and borrow. Let us designate the minuend bit as A and subtrahend bit as B. The result of operation A minus B, all possible values are tabulated below. Right? So we will see the truth table of the hop subtractor. So there are 2 inputs, A and B. Because of 2 inputs, there are 4 possibilities are available. 0, 0, 0, 1, 1, 0, 1, 1. Right? So this thing we already discussed how to perform this 4 operation. So the output is available. Output is the difference and borrow. 0 minus 0 is very simple. Difference is also there is no borrow. Then third one, we will see the second one last. 1 minus 0. From 1 if we subtract 0, again it is difference is 1. There is no borrow. 1 minus 1. From 1 is subtracted means difference is 0, borrow also 0. Right? So for the first combination, third and fourth is very simple. There is no borrow. 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 1 is 0. For the third one, the second one, 0 minus 1. The first number is smaller and second number is bigger. We already discussed that. We have to subtract 0 minus 1. We have to perform the subtraction. So in this case, we need to borrow 1 from the previous digit. So at that time, what will happen? It become 10. Right? Now 10 minus 1 is 1. How it is? 10 is nothing but binary equivalent of the decimal equivalent of 2. So 2 minus 1 is 1. Right? So borrow is 1. We borrow 1 from the previous digit. The difference is also 1. Right? So I will explain again. 0 minus 1. The first number is smaller and second number is bigger. So it is not possible to perform the subtraction. We need to borrow the 1 from the previous digit. While borrow 1, this 0 become 1 0. 1 0 is nothing but decimal equivalent of 2. So 2 minus 1 is 1. So the difference is 1 and borrow also 1. The difference is 1 and borrow also 1. Right? So this is the truth table of the Hop subtractor. Now you need to develop the logical expression for difference and borrow by either by using the K-map or directly from the tabular column also we can develop. So there are two ones are available here for a difference. The second term is 1 and third term is 1. First and fourth is 0. What is the second term? 0 1. 0 1 means A bar B. This is A bar B. The third term is 1 0. 1 0 means A B bar. A B bar. Right? So A B bar plus A bar B. There are two terms available. So A B bar plus A bar B is nothing but A XOR B. XOR gate. XOR operation. Right? Similarly, the borrow only 1 1 is available. What is there? 0 1. 0 means A bar B. A bar B is the borrow. Right? The expression for borrow. Right? So that same thing can be implemented with the K-map also. There are two inputs A B. A available vertically, B available horizontally. Right? So there are two ones are there. 0 1 is 1. 0 1 is 1. 1 0 is 1. Right? So this cell is 0 0. 0 0 is 0. 0 1 is 1. 1 0 also 1. 1 1. The fourth cell is 1 1. 1 1 also 0. Only these two ones are available. So these two ones are available individually, not possible to combine. We have to write the terms individually. So while referring this, we need to refer the second row and first column. Second row is A. The first column is B 0, so that B bar. So A B bar. A B bar. While referring this, we have to refer the first row. First row is 0. 0 means A bar. Second column is 1. 1 means B. Right? A B bar plus A bar B. By using K-map also we can give. Similarly for the borrow, two inputs A B, two combinations 0 1 0 1. So only 1. This is 1. That is 0 1 is the 1. 0 1 is the 1. 0 0 1 0 1 1 is 0 only. Only this one is available. So what is available correspondingly here? 0. 0 means A bar. What is available here? 1. 1 means B. A bar B. Right? From tabular column we can write it directly. Otherwise by using K-map also we can write. So we got the expression for borrow and difference. Borrow is A bar B. Difference is XOR gate of A and B. A XOR of B. Now we need to implement these two expressions using the logic gates in order to get the borrow and difference output. Now we'll go to the logical implementation. So this is the two inputs A and B is available. What is borrow? Borrow is A bar B. Right? So A is available, that is connected with one NOT gate, so that it will become A bar. That is given to one AND gate, because A into B we need one AND gate. And this B is given directly. So B and A bar is given, so that it will give A bar B, borrow. A bar B we need one AND gate. One input is B, another input is A bar. A is available, by using the NOT gate, A bar is given. What is the difference? Difference is nothing but XOR gate. Simply by using XOR gate with input A and B is given directly. We got A B bar plus A bar B. Right? So this XOR gate will produce the output of difference. This AND gate will produce the output of borrow. So that we got the Hop subtractor, we got borrow and difference by using this logical circuit. Right? Here we have AND gate, here we have XOR gate. Now we will see some of the limitations of the hop subtractor. In multi-digit subtraction, we have to subtract the 2 bits along with the borrow. So while subtracting, the borrow is available. So definitely we need to take the account of borrow, right? So 2 bits along with the borrow is the practically available subtractor. Only 2 bit is not available practically. Practically it is impossible, right? So effectively such subtraction require subtraction of 3 bits, right? So it is not, so this is not a possible with hop subtractor. Hop subtractor gives only 2 bits. Practically what we need 2 bits along with the borrow. So that is the there is a limitation of the hop subtractor. But the hop subtractor, by using hop subtractor we can construct the full subtractors. So that still we are using the hop subtractor also, because hop subtractor using we can construct the full subtractors, right? So in this video we discuss about the hop subtractor. What is the truth table? What is the logical expression? That logical expression is implemented with the logic gates. The one limitation is practically we need 3 bit, that is 2 input and 1 borrow. But in hop subtractor we have only 2 bits, that is the limitation. So, but still we are using the hop subtractor because hop subtractor can be used to construct the full subtractors, right? Subscribe this channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.